Hello, my name is Stephanie, and I'm a data scientist on the product development team here at Decoded. And today we're going to be talking a little bit about statistics. So, statistics can mean quite a few things depending on who you're talking to. So, among some disciplines, it's about uncertainty and the mathematics behind that. It can be about more descriptive things like, seeing the mean and the median and the mode of your data. Or it can be about more inferential things. Today, we're going to talk specifically about inferential statistics because that's a really important field in which we test hypotheses and try to build out statistical tests and models to test those hypotheses to answer a broader research question. However, I do want to stress a little bit the importance of the other type of statistics that we can cover. So, the first one I mentioned is called foundational statistics, and this has to do with things like measurement levels of your data. For example, you could have nominal data, which encompasses categories like male or female. You could also have ordinal data, which has a really structured order to it that's even in between and can also be categorical. Then you can have interval data, which has clearly measured intervals between it but may not have an order and can be numeric or categorical. So as you increase in these measurement levels, you get more complex data. So that's just an example of foundational statistics. You can also have descriptive statistics. So when we think about descriptive statistics, that can include things like measures of central tendency. So again, mean, the average of things, or the median, the middle value, or mode, the value that shows up the most in your data. It can also be measures of dispersion or spread, which could include your range, your variance, or standard deviations. And then again, we'll talk about inferential statistics, and that is testing hypotheses and formulating hypotheses using p-values, significance levels, and things like that to get at our basic research question. So our agenda for today is to talk about statistical questions and hypotheses. We'll have a brief, and then we'll talk about some challenges that we'll cover in a Jupyter Notebook and wrap up from there. So what we're going to be focusing on today are reviews of mobile apps, and specifically, we'll be talking a little bit around this question of whether Apple Store users leave better reviews on average than Google Play users. Now, this is a pretty broad research question, or what some people call statistical questions. And this is the question or theme around which our study is going to center today. And it provides us with sort of a foundation or a guidepost from which we can discover the answers to more specific questions. So today that will be what we focus on. And from there, we can derive some statistical hypotheses. So a hypothesis, and in this case, the statistical hypothesis, is a testable statement from which we may gather some data, and we can perform some tests of statistical validity, and provide a conclusion based on the data that we gather. A single research question, like the one we just saw, can have multiple hypotheses. You can just generate one, two, or three, for example, and they allow us to draw conclusions and provide implications for further studying the research question more down the road. So there are some characteristics for what a good hypothesis entails. The first is that it's logical, measurable, and it incorporates variability. So while our research question was pretty broad, we can winnow that down such that we can actually test more specific things. It's well-defined and specific to that point. And number three, it allows us to generalize regardless of whether it is accepted. We don't want it to be so specific that we can only talk about one point in time, for example. We want to be able to talk about a broader population. So we have something that's called the null hypothesis. And the null hypothesis is what most people say they don't want when it comes to doing hypotheses. So here we want to be able to say there are differences between App Store users, right? We want to know who gives better reviews or ratings to Apple or Google. The null hypothesis basically says that there's no difference between the Apple Store and Google Play users. On the flip side, we have what's called an alternative hypothesis, and this is basically saying on the contrary to the null hypothesis, there actually are differences between Google Play users and Apple Store users when they give their reviews on the apps. So in more mathematical terms, we have the H sub O, and you may see this if you find yourself in the maths more frequently than others. And this is also one way to denote the null hypothesis. So this just means that there are no differences between the mean of group A and the mean of group B. H sub A is another way to think about the alternative hypothesis, which means there are differences between the mean of group A and the mean of group B. And if we want to get even a little more mathy here, we can throw in some Greek. So H sub O, again, the null hypothesis, is trying to examine the mean difference between A and B, or mu, and the null hypothesis here says that mu equals 0. So there is no difference between these two groups. And then H sub A would state that the mean difference between A and B, or this mu, isn't 0. So mu does not equal to 0. So all of these things are effectively saying the same thing, just in different notation. So the p-value. I'm going to talk about the p-value in somewhat technical terms to begin, and then I'll talk to you using an example about what a p-value is. So a p-value is defined as a probability, given the null hypothesis is true, that we can obtain results that are equal to or more extreme than the values that we actually observed. Now that's a little bit of a mouthful, I realize, but it's a way that we can measure how much evidence we can leverage against our data when we're testing our hypotheses. So, for example, imagine you have a bag with 200 pebbles in it, and there are red and blue pebbles. Say you take a handful, say 20 pebbles, and you check how many red pebbles you got. You observe 15 out of 20 red pebbles. And you wonder what will be the probability to observe 15 red pebbles out of 20 if in the bag were originally 100 red and 100 blue pebbles. So when you do that calculation, that value is called the p-value. And to calculate that value, you have to know the distribution of the possible scenarios in the bag if it contains 100 red and 100 blue pebbles. And effectively what happens is your computer will generate this value for you, which is really nice and really easy. But the big takeaway about the p-value is that it's pretty subjective. You get to decide how much evidence you're willing to leverage against the null hypothesis here. So if you choose a p-value of, say, 0.05, well, that's all on you, and you need to be able to explain why you've chosen that value, which we'll talk about more in a minute. The next thing we'll talk about are significance levels. And so what you do here is you establish a significance level before you actually calculate the p-value. And it's the threshold that you're going to define if the p-value is enough evidence to reject the null hypothesis or not. So again, this is pretty subjective. It's a little bit tricky because it's arbitrary and you get to choose it. So if you say that you're going to set something at a 95% significance level, that also means that you're willing to be wrong 1 in 20 times or 5 out of 100 times. Is this good? Is this bad? Well, we don't really know. What we do know is what industry standards are or what discipline standards are. So you can generally figure out your significance level and your p-values based on those things. So just to clarify, a significance level is how significant our result has to be for us to reject the null hypothesis. And you define this. It can be 0.3, it can be 0.05, which is usually the conventional standards, or it can be 0.01. And then you can have a confidence level. So this is just saying how confident do we want to be about our test results once we obtain that p-value. And this can be 0.7, 0.75, 0.95, or 95%, which is what we typically do. That's convention in statistics, and 0.99. So keep those things in mind when you're establishing your significance level, you're interpreting your confidence level, and you find your p-value as you test your hypothesis for your research question.